In this recording, we are going to talk about inscribed angles within our circle. We're going to talk about the angle measure compared to the arc that is inside of it. So an inscribed angle is an angle with a vertex on the circle with two sides that are chords. The intercepted arc is the arc that lies between the endpoints of that inscribed angle. And the degree of an inscribed angle is equal to half the measure of its intercepted arc. Okay, so looking at our example over here, we have angle A, B, C. Notice that its vertex, point B, is on the circle. This is different than the central angle. We've learned about the central angles where that vertex was the center of the circle. So this red angle is the central angle. But now we're going to talk about the inscribed angle. So that's the angle whose vertex is actually on the circle. So the sides of that angle are chords, or two segments that go through the circle that have endpoints on the circle. And then the degree of the arc inside of that inscribed angle is half, or the angle is half of the arc. So our angle is half of the measure of arc AC. So if the measure of arc AC was 80, then that means that angle B is 40. Whatever the arc is, that inscribed angle will be half of it. And with that comes our intercepting a diameter. If an inscribed angle intercepts a diameter, then it's going to be a right angle. And let's talk about why. Here we have a diameter, right? So we know that splitting the circle in half, and half of a circle is 180, since an entire circle is 360. So if we have this angle, and the arc inside of it is 180, well, half of 180 is always 90. So if you have an angle intercepting the diameter, it's half of 180. So we can say that the measure of angle BAC is 90 degrees. Okay, so if we have overlapping arcs, that means we're going to have two inscribed angles that are intercepting the same arc. Then those angles are going to have to be congruent. So let's look here. We have angle ABD. Here's the angle, and the arc it's intercepting, or the arc inside of it, is arc AD. But then we also have angle. We have angle ACD, here it is. But notice that the arc inside of it is still arc AD. This arc is the same arc whether we're looking at the red angle or the green angle. And so since they're intercepting the same arc, that means that these two angles have to be congruent. So we can say that the measure of angle ABD has to be equal to the measure of angle ACD. And each of those angles, they're going to be half the measure of arc AD, since they are inscribed angles intercepting arc AD. So using that idea, we can solve these problems involving our inscribed angle. One way that I like to put it on the paper is I like to say that an inscribed angle, so the angle is half of the arc. So looking at number 1, it wants to know about angle, the measure of angle WXY. WXY is this angle here. So the angle is half of the arc. The angle is what's missing. Let's call it X. The arc is labeled as 62 degrees. So half of 62 is 31. So the measure of this angle, WXY, is 31 degrees. Simple as that. Let's look at number 2. Number 2, we have angle DEF. We know that's 113. And the arc inside of it is arc DGF. So the angle will be half of the arc inside of it. The angle was given to us this time. We're looking for the measure of the arc. And you can call that arc whatever variable you want. I like x. Well, to get rid of this 1/2, I'm going to need to multiply both sides by 2. So I get 226 is the measure of that whole big arc, which makes sense, right? It's 226 degrees. That's a large portion of that circle that's highlighted. So 226 out of that 360 is a pretty large portion of the total 360 degrees. In number 3, I see a diameter. See the diameter there? We know the diameter is splitting the circle in half. It wants to know about the measure of angle PQR. That's this angle right here. Okay, well, the arc inside of angle PQR is half of a circle. So if the angle is half of the arc, and the angle is what we're looking for, well, this arc is half of a circle, which is 180, and half of 180, of course, is 90 degrees. If you didn't want to go through this whole process and just recognize that the angle was intercepting the diameter, then you could just jump straight to saying, oh, well, it has to be 90. All right, with those 3 examples, I would like you to try number 4. But in number 4, what I'd like you to start with, instead of jumping straight to finding the measure of arc BC, first, can you find the measure of arc AC? So start there. Find the measure of arc AC, and then together we'll talk about how to find the measure of arc BC. So in number 4, find the measure of arc AC. Do that now. Okay, so the given inscribed angle, angle ABC, was 47 degrees. And since it's an inscribed angle, that means its measure is half of the arc inside of it. So I can say the angle is half of the arc. The angle is 47. The arc is what we were missing or looking for. So I just gave that the variable x. To get rid of this 1/2, let's multiply both sides by 2. So that means that arc AC is 94. Now let's actually answer the question I was asking. If we know that the arc AC is 94 and BA is a diameter, then I know that whatever this piece is out here has to add to 94 to get 180. So let's see, I'll make it blue. This arc here, whatever it is, has to add to 94 to get 180. So let's call it y. Y plus 94 equals 180. So now that we have that set up, we can solve for y. So we'll just subtract 94 from both sides. And we get 86. So that means that the blue arc here is 86 degrees. So the measure of arc BC, 86. All right, let's look at number 5. Number 5, it's asking us to find the measure of angle JKL. That's this angle here. Well, the angle will be half of the arc inside of it. The arc inside of it, though, is here. That's not labeled. How do you think we can find the measure of this arc given what's in the picture? Yeah, these 3 arcs together, they have to add up to 360. So 53, 65, and that blue arc have to add up to 360. So if I do 360 minus 53 minus 65, that tells me that that blue arc is 242 degrees. Okay, so the angle, which is what we're looking for, let's call it x, is half of the arc inside of it, and the arc inside of it is 242. So half of 242 is 121. So the measure of that angle is 121 degrees. All right, so let's look at number 6. In number 6, we have this circle, and we've got, I see a bunch of inscribed angles, right? Like this is an inscribed angle, and this is an inscribed angle, and this one, and this one. And an inscribed angle is just an angle whose vertex is on the circle. So there's lots to figure out here. But what it's asking us for, that could be helpful. It's asking us for angle RST. Well, angle RST is this angle. And it's asking us for angle RUT. Interesting. Okay, well, the arc inside of angle RST is arc RT. See how the yellow arc is the arc that's inside the red angle? And that just happens to be the same arc inside the green angle. So that tells me that these two angles are intercepting the same arc. So whatever they are, they're going to be equal. They're going to be the same number. So I don't know what that number is yet, but I know that whatever the measure of one is, it'll be the measure of the other. Okay, so if we can find the measure of that yellow arc, then we'll be golden. Oh, hey, look, 64, 139, and 75. We already know these three. So the yellow arc plus 64 plus 139 plus 75, they all have to add up to 360. I'm going to call that yellow arc X. Okay, so if you need to see that, here it is. That's a plus. And we can solve for X. I'm just going to take that 360 and subtract 64, 75, and 139. So my yellow arc is now 82 degrees. Great. That yellow arc is the arc inside the red angle. The angle is half of the arc. The arc is 82. So half of 82 is 41. So angle RST is 41 degrees. Angle RUT is intercepting the same arc, so it's going to be the same measure. If you didn't recognize that they were intercepting the same arc, then you would have said, oh, well, angle RUT is half of the arc inside of it, which is still 82, and you still would have gotten 41. Okay. The next slide, we have examples with intercepted arcs, but a little bit more algebra this time. In number 7, our angle is angle CDE. It's an inscribed angle because its vertex, D, is on the circle. The arc inside of it is 158. So an inscribed angle is half of the arc inside of it. Okay, so in this case, the angle is 8x minus 9. That's going to be half of the arc inside of it. The arc inside of it is 158. So I can say half of 158 is 79. And now we just need to solve for X using our algebra skills. Add 9 to both sides. Divide both sides by 8. X equals 11. So if you can remember, for an inscribed angle, the angle is half of the arc, then you can replace whatever you know about the angle or the arc, depending on what's given, and solve for what you need to. So in number 8, we have an inscribed angle and an arc inside of it. So if the angle is half of the arc, replace what you know about the angle in the angle part, and replace what you know about the arc for the arc part of the equation. Go ahead and try this one now. So the angle in this case was 67. They had that angle labeled as 67, so I replaced the angle with a 67. The arc inside of it is labeled as 4x plus 58, so I replaced the measure of the arc in the formula with 4x plus 58. Now there are different ways to solve this algebraically. If you don't like that 1/2, maybe you multiplied both sides by 2 to get rid of it. That's okay. I just distributed the 1/2. I usually don't like to distribute a fraction, but because I recognized these both to be even numbers, I knew that dividing them by 2 would come out to still be a nice number. So I distributed the 1/2. Half of 4x was 2x, half of 58 was 29. And now we can solve this. Subtract 29 from both sides, divide both sides by 2. So you should have gotten x equals 19. If you solved this algebraically but different than me, and you still got x equals 19, that's great. If you didn't and you can't find your error, you are welcome to snap a picture or take a screenshot and send it, and I can help you find that error. We can fix that together. All right, and now we just have a whole bunch more examples, all with algebra. Looking at number 9, I see a diameter. See that diameter there? Oops. Let me get my pen back. There's the diameter. Diameter splits a circle in half, which means this arc has to be 180. So if they show you the diameter, they are not going to label the semicircle. They're going to make you label it and assume that you know, which is never safe, but make you know that a semicircle is 180. They're not going to label it for you. So anytime you see that semicircle, you can go ahead and label it as 180 if you want. Now, maybe you recognize that this angle is intercepting the diameter, so this has to be a 90-degree angle because 90 is half of 180. So we can say, oh, well, this 13x minus 1, it has to be 90. If you didn't see it that way, then you maybe said the angle is half the arc inside of it. Well, half of 180 is 90. So that little theorem helps us just kind of skip that first step. But you don't have to skip the first step if you don't want to. You can just say it's half of the semicircle and move on. And that's fine. See, I'm going to add a 1 to both sides and then divide both sides by 13. Ta-da! There it is. X equals 7. All right, let's see. Let's look at number 10. Number 10, we need to solve for x. X is an expression for this angle right here. I don't know the arc inside of that angle, though. Here's the angle, the whole thing. The arc inside of it is arc xy, but I don't know the measure of arc xy, and wy is not a diameter, so that's not going to be helpful. So let's see. Ah, look at that 114. That 114 is going to come in handy here. So let's look at angle 1, that angle 114. It's this angle right here. That's an inscribed angle, and the arc inside of it is here. So I can say that the angle is half of the arc. And so if the angle is 114, then let's say that the arc here, we'll multiply both sides by 2. So we get 228 is the measure of the arc. So this arc out here is 228. That's going to come in handy because now I can figure out the measure of the arc that's missing. You can find out the measure of arc xy. Because that 78, that blue arc, whatever it is, let's call it x. Oh, no, not x. X was already used. How about y? And the 228, all three of those arcs together have to make 360. So now we can find that missing arc. 360 minus 78 minus 228 is 54. So the blue arc is 54 degrees. There we go, which is very helpful now because we have this angle and now we know the arc inside of it. I've run out of space. Let's use red. So the angle, I'm going to do it up here, is half of the arc inside of it. So the angle is labeled as 7x plus 6, and the arc inside of it is 54. Oops, I need half of that. Half of 54. So 7x plus 6 Half of 54 is 27. Let's subtract 6 from both sides and divide both sides by 7. Okay, so this one was a little trickier because we had to find an arc that wasn't even being asked for in order to find the arc we needed to solve for x. Okay, I would like you to use this idea of the inscribed angle being half of the arc inside of it. If you don't know the arc inside of it, using what you know about a circle, like the entire measure is 360, to help you find whatever missing arc you need in order to solve your problem. You're going to use those ideas at number 11 and in number 12. I'd like you to try those two now. Okay, so for number 11, you should have gotten x equals 9. It didn't tell us the measure of arc AC, but since we know that the entire circle is 360, we can do 360 minus 92 minus 162, and that will tell me the measure of this arc. So the measure of arc AC is 106. The angle that makes that arc is labeled as 7x minus 10, so I can say the angle is half of the arc inside of it. The angle is half of the arc inside of it. Half of 106 is 53. So I can add 10 to both sides and divide by 7. So that's where that x equals 9 came from. Over here, number 12, we needed to solve for x. X was labeling an arc, and I don't even know an angle that makes that arc. But I do know that these three arcs altogether make 360. So if I can find the measure of arc QS, then I can say, oh, arc RQ plus arc QS plus arc SR has to add up to 360. And I know the measure of angle R here. The angle is half of the arc inside of it. So 67 times 2 tells me the measure of arc QS, 134. So then I can say, oh, all three of these arcs added up, get me 360. So that's what I did. I added the three arcs together and got the 360. Combine like terms, 120, 134, and 21. That's where the 275 came from. Subtract 275 from both sides, and then divide both sides by 5. So you should get x equals 17. Now, sometimes they're going to give you a problem, and the given information is not going to be marked in the picture. That's okay. You can mark it in the picture yourself. And if you're using a scrap piece of paper or a whiteboard, then you just sketch the picture that you see here and put the given information in that picture. So the measure of angle FGH is 6x plus 21. So I'm going to go ahead and label that here. And the measure of arc FJH is 17x minus 28. And we're going to find the measure of arc FJH. So looking at the information now that it's in the picture tells me that I have the angle and I have the arc inside of it. So we can say, oh, the angle is half of the arc inside of it. The angle is 6x plus 21, and the arc inside of it is 17x minus 28. Now this one, I don't want to distribute that 1/2, because when I do, I'm going to take half of 17, which is going to give me a decimal. And I just don't want to deal with that decimal. So I'm going to do something a little different algebraically, and I'm going to multiply everything by 2. Multiplying this side by 2 will get rid of that 1/2, which is what I want. But I can't just multiply one side by 2. I have to multiply both sides by 2. So I end up with 12x plus 42 equals 17x minus 28. If you would rather distribute that 1/2 and deal with the decimal, that's okay. That's fine with me. I don't want to play with the decimal. So I'm just multiplying both sides by 2 to get rid of that 1/2. And now I don't have any decimals. I don't have any fractions. I just have these whole numbers to deal with. So I'm going to subtract 12x from both sides. And then add a 28 to both sides. What do I get? 70. And then divide both sides by 5. So x equals 14. Now, if this was a multiple choice question, we promise you that 14 would be an option, but 14 is not the answer. We need to find the measure of arc FJH. So we're going to take that 14 and we're going to plug it in for arc FJH. So the measure of arc FJH is 17 times 14 minus 28. And we get, when we type that all into the calculator, 210 degrees. If you wanted to check it, you could also plug it in here to the angle. 6 times 14 plus 21, we get 105. That had better be half of the arc inside of it. And it is. 105 is half of 210. So that checks out. All right, and number 14, they're telling us the measure of angle STU. They're telling us the measure of arc SU, and we need to find the measure of angle STU. So we need to set up an equation, solve for x, take that x and plug it back in, and find the measure of angle STU. I'd like you to try this one now. All right, so they gave us the angle. They gave us the arc inside of it, so we just needed to set up the equation. The inscribed angle is half of the arc inside of it. The angle was 5x minus 16. The arc is here in green, 12x minus 50, and I wanted half of it since I need half of the arc. And I just multiplied both sides by 2 again, just to show you that process one more time. To get rid of the half, I can multiply by 2, because 2 times a half is 1. But if I'm going to multiply the right side by 2, then I have to multiply the left side by 2 also. So I get 10x minus 32 equals 12x minus 50, since this 1/2 and this 2 canceled out. I subtracted 10x from both sides, leaving me with negative 32 equals 2x minus 50. Add 50 to both sides. 50 minus 32 is 18. Divide both sides by 2, we get x equals 9. So to answer the question, the measure of angle STU, I'm going to take that 9 and plug it into the expression for angle STU. 5 times 9 minus 16 is 29 degrees. So the measure of angle STU is 29 degrees. Okay, and number 15, they tell us the measure of angle ABD. I'm going to go ahead and label that. Angle ABD is this angle here. And there's really not a lot of space there, so I'm going to write that out here. 6x plus 26. We'll just put an arrow there. And then angle ACD. ACD is here. That angle is 13x minus 9. That's this angle. Notice that they both intercept the same arc. Arc AD. Arc AD is the arc inside both of those, whether you're looking at the green angle or the red one, they both intercept arc AD. So whatever arc AD is, we know that these two angles have to be congruent because they're intercepting the same arc. So at the end, we're going to find the measure of arc AD, but let's first find x. Since these two angles have to be congruent, that means that their expressions have to be equal. So now we can solve for x. We can subtract 6x from both sides, add a 9 to both sides, and divide both sides by 7. Okay, so now we know x. Nice. We can use that to help us find arc AD. We can take this x and we can plug it in to either one. It doesn't matter. We're going to get the same number. 6 times 5 plus 26, or 13 times 5 minus 9. Either way, these angles are 56 degrees. Okay, well, if the angle is 56, let's find the arc inside of it. The angle is half of the arc inside of it. The angle is 56. Let's find the arc. So let's multiply both sides by 2. So the measure of that arc, which is actually arc AD, is 112 degrees. All right, number 16, our last problem for this video. We are given an expression for angle KLJ. It's this angle right here. That's 3x plus 2. I'm just going to do this since I can't write it in there. and angle KLJ. KJL, I put that in the wrong spot, silly me. I know my alphabet. Let me try that again. Okay, KJL, that's this one. 3x plus 2. There it is. And KLJ, now that's this one. So this angle is 7x minus 32. We're going to find the measure of arc KL. Woo. All right, so before we find the measure of arc KL, let's solve for x. Now these two angles aren't going to be congruent. They're not intercepting the same arc. My green angle is intercepting arc KL, and the red angle is intercepting arc KJ. But we know the measure of angle LKJ. Do you know what it is? You know what the measure of angle K is? Yeah, that's 90 degrees. It's intercepting the diameter. So it has to be a 90-degree angle. Okay, now our properties of triangles are going to come back to us here. We have a 90, we have a 3x plus 2, and we have a 7x minus 32. We know that the three angles in a triangle always add up to 180. So we can solve for x using that property of triangles. Combine our like terms. What is this? 10x plus 60. Subtract 60 from both sides. Divide by 10. There we go. Now we know x equals 12. So now that I know x equals 12, I'm going to come up here and plug it in. 3 times 12 is 36, plus 2 is 38. All right, this angle is 38. That is helpful to find arc KL. Arc KL is the angle, the arc inside of this angle. So the angle is half of the arc when it's an inscribed angle, and the angle is 38. So now we can find arc KL. Multiply both sides by 2. So the measure of arc KL is 76 degrees. Okay, that was inscribed angles. We're going to continue to practice those. There are practice problems available for you also if you would like to practice more of them. You can also bring questions to office hours or email, and I'm happy to help. Have a great day.